You've probably used something like ChatGPT, right? But have you ever stopped to think about what's actually powering it? Well, it's not magic. It's an absolutely massive symphony of hardware. Today, we're going to pull back the curtain on the powerful engines that drive large language models. So, let's get into it.
We've got a lot to cover. We'll start with why this hardware is so critical in the first place. Then we'll break down all the essential parts, talk about optimization, and wade into the whole on-prem versus cloud debate. After that, we'll settle the big one, GPU versus CPU. And finally, we'll map out the entire hardware ecosystem for you.
So, first up, why are we even talking about hardware? Well, it's because LLMs are incredibly, almost unbelievably demanding. They're processing these giant datasets and making trillions of calculations. The hardware isn't just some minor detail here. It is the absolute foundation everything is built on.
And that's the key right there. It's not just about clever code. The entire physical stack, from the moment a developer starts training a model to the second you get a response, it all rides on this hardware. It is the non-negotiable, gotta-have-it ingredient at every single step of the process.
Okay, so if you were going to build a machine that's ready to handle an LLM, what are the key parts you'd actually need? Let's take a look under the hood and break down those core components.
At the very heart of the system, you've got the processors. You can kind of think of them as the brain of the AI. But here's the thing, it's not just one type of brain. It's more like a specialized team where each member has a very specific and very crucial job to do.
First up, we have the Central Processing Unit, the CPU. Think of the CPU as the system's general manager. It's handling the operating system, running the background processes, and just making sure everything keeps ticking along smoothly. It's absolutely essential, for sure, but when it comes to AI, it's not really the star of the show.
And that brings us to the real star, the Graphics Processing Unit, or GPU. These things are the heavy lifters. See, unlike a CPU that handles tasks one after another, a GPU can perform thousands of calculations all at the same time. This parallel processing power is exactly what LLMs need to chew through those enormous datasets. They are, without a doubt, the true workhorses of the AI world.
But hey, those processors can't do it all alone. They need a really strong supporting cast. You've got memory, or RAM, which is like their super fast short-term workspace. Then you have storage. That's the long-term library where the models and all the data live. And finally, high-speed networking. That's the nervous system that connects all the pieces, which is especially critical in these massive distributed systems.
So you've got all this amazing, powerful hardware, but just having it is really only the first step. The next big challenge is optimizing it all. How do you tune these components to get the absolute best performance, efficiency, and, this is a big one, cost?
You know, optimization is this constant balancing act. You're always juggling four key things. You want to squeeze out every drop of performance, but you have to control your costs. And you need this system to be reliable while also making sure it can scale up when you need it. Getting that balance just right, that's the secret sauce to a successful infrastructure.
And that whole balancing act leads you to a really fundamental choice, maybe the biggest one you'll make. Do you build it all yourself, which we call on-premises, or do you rent it from a provider like AWS or Google, which of course is the cloud? It's the classic build versus buy dilemma.
Honestly, the choice really comes down to a classic trade-off. On-prem gives you total control and potentially higher security, but it comes with a huge upfront investment in hardware and people. The cloud, on the other hand, lets you get started with a way lower initial cost, and you can scale up or down instantly. The catch? You're renting the infrastructure instead of owning it.
Yeah, going the on-prem route is a major, major commitment. You become responsible for the entire life cycle. We're talking everything from assessing and buying the hardware to the physical setup, all the way to the ongoing day-to-day maintenance. It is a huge undertaking that requires a really dedicated team. With the cloud, your focus totally shifts. Instead of managing physical boxes in a server room, you're picking a provider and provisioning resources through a website. Now, you still have to handle configuration and security, of course, but all the heavy lifting of physical maintenance and scaling, that's done for you.
Okay, let's zoom in on what is probably the most important hardware debate for anyone working with LLMs. We're talking about the big one, the battle between GPUs and CPUs. We already said GPUs are the workhorses, but why? What is the real fundamental difference?
All right, for anyone out there who's familiar with databases, this is the perfect analogy. A CPU is like a high-speed transactional database server. It is brilliant at executing one complex instruction very, very fast. A GPU, though, is like a massive data warehouse. It's designed to run thousands of simpler queries all at the same time in parallel across a huge data set. And that's the thing. Training and running LLMs is a data warehouse problem, not a transaction problem. They need the warehouse.
So when you break it all down, it looks like this. GPUs are built for the parallel tasks that are essential to LLMs, which makes them perfect for scaling out in these huge clusters. And yeah, they cost more per unit, but their performance makes them pretty much the only real choice for serious AI work. CPUs are great for running the rest of the system, but for the actual heavy lifting, GPUs are king.
So now we get the components, we get the strategies. Let's zoom out and look at the bigger picture. Who are the actual companies building these chips and cloud platforms that are powering this entire AI revolution? Well, it turns out a few giants really dominate this whole landscape. NVIDIA is the undisputed leader in GPUs, that essential chip for AI. AMD and Intel are, of course, fierce competitors. And then you've got the cloud titans, like Google and AWS, who are kind of playing both sides of the field. They're providing access to all these chips, but they're also developing their own custom hardware to try and get an edge. And if you really want to understand the scale we're talking about, just look at something like ChatGPT. It doesn't run on one computer or even 100. It runs on a massive, sprawling cluster of tens of thousands of GPUs. That is the mind-boggling level of parallel power you need to both train the model and serve answers to millions of users at the same time. And this isn't just for closed proprietary models. If you want to run a powerful open-source model like Llama 2, you face the exact same challenge. You have to carefully figure out what it needs, get your hands on the right GPUs, and then configure all the high-speed networking to make all those pieces work together like they're one giant machine.
So let's wrap this up with the key takeaways. First, LLMs need specialized parallel processing hardware. There's no way around it. Second, GPUs are the absolute workhorses, but they totally rely on the supporting cast of CPUs, memory, and networking. Third, that big on-prem versus cloud decision all comes down to a trade-off between control, cost, and scale. And finally, really understanding this hardware stack is the first, most crucial step to unlocking an LLM's true potential.
You know, the hardware is the canvas, and the models are the paint. The possibilities are, well, they're pretty much endless. We've just walked through the blueprints for the engine of modern AI. So the only real question left is, what are you going to build with it?
If you found this explainer helpful, we'd really appreciate it if you'd hit that like button, share it with someone who might be interested, and subscribe for more. Thanks for watching.